Welcome to class, everyone. Go ahead and grab your seats and get settled in, because today we are diving into what is arguably the most epic history lesson imaginable. We're going to explore how the entire universe evolved, how our planet came to be, and how absolutely everything lined up just right to make human life possible. As your teacher today, I promise you, this lesson is going to completely change the way you look at time.
All right, let's jump right in. Imagine I'm writing this giant number right here on the chalkboard, 13.8 billion. That is the approximate age of our universe in years. It's a number so staggeringly huge that our human brains, which are, used to thinking in days or seasons or maybe decades at most, just can't truly process it. It's literally like trying to picture every single grain of sand on Earth.
So that brings us to the big question for today's class. How can we possibly wrap our heads around these massive timescales of cosmic history? I mean, if we can't comprehend billions of years, how do we understand our place in the universe? How do we even trace the incredible chain of events that led to you and me sitting right here, right now?
Well, to solve this problem, we're going to use a brilliant idea from the famous astronomer Carl Sagan. He came up with this amazing thought experiment called the cosmic calendar. Basically, he compressed the entire history of the cosmos, all 13.8 billion years of it, into a single standard Earth year. So January 1st is the Big Bang, and right now, this very moment, is the final stroke of midnight on December 31st. It's a genius way to visualize deep time so we can actually understand it. Before we start our journey, let's check out this cheat sheet. On our cosmic calendar, a single month represents over 1 billion real years. One day covers almost 38 million years. And just one tick of the clock, one cosmic second, equals 438 years in real time. Keep that in mind, 438 years in just 1 second. That's going to blow your mind later on.
Okay, here is our lesson plan for today. We're going to do a quick intro to the cosmic calendar, then we'll look at the formation of the early universe, the birth of our solar system, how life absolutely took over Earth in December, and finally humanity's very late arrival in the last seconds. All right, Module 1, Introduction to the Cosmic Calendar. Get ready for a major perspective shift.
Here's the key takeaway. If the universe is just 1 year old, then literally everything you have ever studied in a history class, every empire that rose and fell, every single war, every book ever written, from the first clay tablets in Mesopotamia all the way to that smartphone in your pocket, all of it fits into just the final 14 seconds of December 31st. We are incredibly late to this party, guys, and to understand how we even got to those last seconds, we have to rewind the clock all the way back to the very beginning.
Which brings us to Module 2, Formation of the Early Universe. We're starting right on New Year's Day.
In the very beginning, the universe was incredibly simple. After the Big Bang cooled down a bit, the very first stars formed, and they were made of just two things, about 75% hydrogen and 25% helium. But these early stars were like massive cosmic forges. Deep inside their cores, nuclear fusion started creating heavier elements, things like carbon, oxygen, and iron. And those are absolutely crucial for making planets and eventually biology. But you know what? Those elements would be completely useless if they just stayed locked up inside. Luckily for us, those early massive stars lived really short lives, and they died in spectacular supernova explosions. When they blew up, they scattered all their chemically enriched guts across the cosmos. That stellar recycling program is literally the only reason we have the building blocks for life today. Let's map this out on our calendar. The Big Bang kicks off the year at midnight on January 1st. About a week later, around January 8th, those first stars ignite, ending the cosmic dark ages. And as gravity pulls those stars and gas clouds together, our very own cosmic neighborhood, the Milky Way galaxy, finally forms around March 15th. Boom, we made it through the spring.
Moving right along to Module 3, Birth of the Solar System.
So after the universe spends the long, quiet summer months just churning out new stars and galaxies, we arrive at a huge milestone. On September 1st, after 9 billion years of the universe enriching itself with heavy elements, our sun forms in this totally average spiral arm of the Milky Way. Just 2 days later, on September 3rd, Earth forms from the debris, followed quickly by a massive collision that creates our moon. And surprisingly fast, by September 21st, the very first glimmers of simple, single-celled life appear in our oceans.
But getting from simple bacteria to you and me, yeah, that wasn't a straight line. This brings us to something called the rare Earth hypothesis. The idea here is that while simple microbes might be pretty common in the universe, complex life requires an incredibly specific, mathematically improbable chain of events. Earth had to be right in the perfect habitable zone for liquid water. We needed a giant planet like Jupiter to act as a gravitational shield to deflect dangerous asteroids. Everything had to be perfectly tuned for billions of years. And because evolving is so incredibly hard, life on Earth stayed as simple microscopic forms through the entire fall, all of October and November.
All right, Module 4, December. This is when life really takes over Earth.
December is an unbelievably busy month on the calendar. On December 17th, we get the Cambrian explosion, just this sudden biological frenzy where complex hard-shelled animals appear. By December 20th, plants finally colonize the land, turning the continents green. Dinosaurs, they show up exactly on Christmas Day, December 25th. And just one day later, on the 26th, the very first small mammals scurry onto the scene. Now, the dinosaurs were incredibly successful. They ruled the Earth for almost 5 full cosmic days. But then, we get a pretty humbling reality check. At 6:24 a.m. on December 30th, which is literally just yesterday in our cosmic year, a massive asteroid slams into Earth, ending the Cretaceous period and totally wiping out the non-avian dinosaurs. But their bad luck was a golden opportunity for our ancestors. With the giant reptiles gone, mammals started evolving rapidly. Which brings us to our final module, the last seconds, where humanity finally appears. It is now December 31st. At 9 p.m., our early hominid ancestors finally stand upright and start walking on 2 legs. At 11:44 p.m., they domesticate fire, which is a massive leap forward. And finally, at 11:52 p.m., just 8 minutes before midnight on the very last day of the year, anatomically modern Homo sapiens arrive on the scene. Now let's watch these crazy final seconds tick down. At 11:59 and 38 seconds, we invent agriculture, which lets us settle down. At 11:59 and 50 seconds, the Egyptian pyramids are built. At 11:59 and 59 seconds, just 1 second before midnight, we see the European Renaissance, the invention of the telescope, and literally all of modern science and technology. Everything from the steam engine to landing on the moon happens in one single cosmic blink.
And here is where the perspective shift gets really wild. If you assume an average lifespan of about 80 years, one single human life takes up about 0.2 cosmic seconds. That means if you're a student sitting in my class right now, your entire life takes up just 0.05 seconds before midnight.
When you see numbers like that, it's pretty easy to feel insignificant. But Carl Sagan looked at it differently. He said, what happens next in our cosmic calendar depends on how we use our intelligence, on what we do now. The universe spent almost an entire year laying the groundwork, forging elements, building planets, nurturing complex life, all so that in the very last fraction of the second, one species could wake up and actually understand it all.
So, class, as we wrap up our lesson for today, the clock is striking midnight. A brand new cosmic year is starting. The institutions, technologies, and societies we've built are only a few seconds old. We are holding this incredible, inspiring responsibility. And I want to dismiss you today with one final provocative question. What will we do with the first second of the next cosmic year? Class dismissed.